All right, I'm going to go through this problem step by step. So I'm probably scaring some of you with 205 coming back. So I'm going to go through it as if you didn't have 205. So just refresher. So they give you a joint PDF where it's defined to be piecewise 6y1 squared y2, where y1's, this is important actually, they give you a region over here where this function is valid and 0 everywhere else. So you need to kind of pay attention to that. You'll see as I move along. So the first step is to draw that region to determine the limits of integration. So I can't remember what the problem is asking for. I think it was to verify that this was indeed a probability distribution function, or density function. So what it wanted was for you to do the double integral and show that you get 1. That's what they wanted. So you have to calculate this double integral. And the first step is to take this region and draw these limits of integration. So how do you do that? Well, you start just drawing it out. The first one is that the first piece is this y1 less or equal y2. Just graph y1 equals y2, just the line, to represent that first boundary. The second boundary is y1 plus y2 is equal to 2. And that's that green line over here. You get equality going this way. And then you have to look at what these inequalities say. The first one says that it has to be in the upper quadrant. If they gave you good problems in 205, they would give you things where you think it might be in the first quadrant and it's not. So just be careful that you're following everything exactly as it's told. So right here, what tells me it's in the first quadrant is that both y1 and y2 are bigger or equal 0. Then the second one, it tells me that y2, which is my y-axis, the y2 values have to be smaller than or equal to this line. So that's how I read it, that y2 has to be smaller than this line. So it's got to be under the green line in the first quadrant, and y2 also has to be above y1. So y2's got to be above that line. So the triple shaded region, so y2's got to be above this line, y2's got to be below this line, and it's got to be in the first quadrant. So we get this triangular region here. Good? All right, so that's my picture. If you're still writing, let me know from the previous. You're fine? Okay, so how do you get the limits of integration? I usually go y2 first because it's easier for me to see. So you just shoot an arrow from the bottom of your picture to the top. Wherever your arrow enters, that's your bottom limit. Wherever your arrow exits, that's your top limit. So it enters in at the line y1 is equal to y2, and it exits at the line y2 is equal to minus y1 plus 2. How do you figure out where the x-axis limits are? You just look at where your picture stops, your shaded picture stops. Your shaded picture starts at y1 equals 0, and your shaded picture ends at y1 equals 1. So now you can set up your integral. The hard part is always those limits of integration. That's the integral I need to compute. Someone asked Colonel Clark, do I have to write this every time? Yeah, actually, there's a problem I'm going to give you as a board problem that if you don't write this out, you get something wrong for the cumulative distribution function. So it's easy to, you have to remember that you're working off this infinite set. So this is the definition. You want to find out if this is actually equal to 1. So this is equal to, I don't know why I wrote it twice. Limits of integration, I started out at y2 equals y1, that was the first line, and the second line was y2 is equal to minus y1 plus 2, and the limits of integration here are 0 to 1. And notice that I write this down here. The book doesn't actually, and I think they have an error somewhere in the book where they didn't match up those limits of integration with the integration. This tells you that do integration with respect to y2 first. That's why this inner integral has y2 equals y1 and y2 equals. Those things have to match up. And these two guys have to match up. y1 equality right here has to match up with the outer integral. So I'm really, really careful about these things because this is what I call a bookkeeping problem. It's not, there's no thought in it. I know there's no thought in it because Wolfram Alpha can do it. So there's no thought thinking about it. It's just about making sure you have everything correctly put in there. And once you have the limits of integration, I just punched it into Wolfram Alpha on my phone. I didn't even have my computer next to me, and I got one. Good? Happy to see some of this coming back? Don't look so enthused. All right, so the next question they ask is, what is the probability y1 plus y2 is less than 1? So you rewrite this puppy so that it's y2 is less than minus y1 plus 1. So I think of y2 as being the y and the y1 as being the x. So you can see me reordering this. I'm a creature of habit. I like to have routine in what I'm doing, so I kind of keep everything I'm doing the same. So I always integrate with respect to y2 first and integrate with y1 the second. If they force me to go the other way, I just turn my graph around and then do it the way I used to do it. So y2 first, y1 second. So I'm solving for the y2 as if it was the y. So recall that this was the original picture that we had. There's a new picture in there now. If you look at y2 is minus y1 plus 1, this line over here, I made a red line there. So you can see that's the graph of y2 equals minus y1 plus 1. Now y2 has to be smaller than that, but still be in that blue region I shaded at the beginning. Well, that's that region right there. And so the hard part of this is just figuring out this region part. And you know, if you have an uncomfortable feeling and didn't like 205, that was the same hard part in the double integrals from 205. So I do the same old business. Shoot an arrow from the bottom up. So it goes in at the line y1 equals y2. It goes out through the line y2 is equal to minus y1 plus 1. That's the red line. See, it's exiting out this red line right here. And then y1 is equal to 0 to 1/2. Where did I get that 1/2 from?
From the intersection of the two.
Right. In fact, you can eyeball it and figure out where it's supposed to come. You don't even have to do algebra. Notice that those match again. So I label my indices. It actually can go haywire pretty quickly with all these letters. So I really recommend that you're writing down and labeling everything. Okay. And then once you have the limits of integration, I'll ask Colonel Clark if, I think he would be the stickler if he doesn't allow you to use Mathematica. Mathematica, I believe you can even give it the region and it will do the whole thing for you, but he's actually adamant that you do them by hand and be able to do them, so I'll ask him. If that's the case, maybe we should do some of those. I'll ask him today, all the way through so you can see all the calculations. To me, this is like, oh, this is, it's power law for integration, and it's bookkeeping. So if you got to this point and can't integrate a polynomial, that's not, everybody in here can integrate a polynomial. Okay, any questions? You're worried about that you can't integrate a polynomial? I said everybody can integrate a polynomial. She looked over at Hollis.
Well, I said I could. I don't know about anymore.
You can. Add 1, divide by that number. X to the n plus 1 divided by n plus 1. Good?